So the next problem reads as following. A plane lands on the deck of an aircraft carrier. So we are probably at sea and have a aircraft carrier over here. And a plane comes on, flying, and lands on the aircraft carrier. And they tell me that the initial velocity was of 90 meters per second, and then the plane stopped completely. What does that mean? That the final velocity is equal to 0 meters per second. Since the plane stopped completely, final velocity 0 meters per second. At a distance of 100 meters. Find the acceleration and the time to stop it. Alright. What's the acceleration and the time to stop the plane? So let's see, my data gives me the initial velocity, 90 meters per second. Final velocity, as I said previously, 0 meters per second. And a distance, x equals 100 meters. I'm gonna see my formulas, alright? I'm gonna use this one. Why? Because I have the distance, initial and final velocity, divided by 2, and then I can get the time. So it will be distance, 100 meters, is equal to the initial plus final velocity. The initial velocity is 90 meters per second, plus final velocity of 0 meters per second over 2 times time. So I'm gonna solve the following. I'm gonna pass this down. This is multiplying, this must go dividing. 100 divided by 45 will be 2.22 seconds. The time is 2.22 seconds. Yes, because we have meters over here. When we pass dividing, we eliminate meters with meters, and we are left with seconds because of the law of the tortilla. So that would be the time. And now I can use this formula to find the acceleration. I have the final velocity is equal to 0, initial velocity 90 meters per second, plus acceleration times time, 2.22 seconds. So it is going to go to the other side, negative. And we have the time that goes dividing, alright? So it will be 19. We divide this, and it's going to give me a negative acceleration of 40.54. We have the law of the tortilla, meters, seconds times seconds, seconds squared. So the acceleration is minus 40.54 meters over second squared. Why is the acceleration negative? Because the plane slows down. So this would be...
Okay, here we have the final problem. Initially, a train traveling at 16 meters per second accelerates constantly at a rate of 2 meters per second in the same direction. How far will it travel in 20 seconds? And what will be its final speed? Here we have the initial velocity of 16 meters per second, the acceleration of 2 meters per second squared, and the time of 20 seconds. So we need the final velocity and the distance that equals x. So the formula of final velocity is initial velocity plus acceleration times time. So we have 16 meters per second plus acceleration 2 meters per second squared times time, 20 seconds. Here it's second over second, so we eliminate. And we have 20 times 2 plus 60. We have 56 meters per second. And this will be the final velocity. And then we need the distance. That it will be initial velocity plus final velocity over 2 times time. And this is going to be initial velocity of 16 meters per second plus final velocity of 56 meters per second over 2 times 20 seconds. And we're first going to make this 16 plus 56, 72 over 2, 36 meters per second times 20 seconds. And this will be 720. We eliminate seconds and we have meters. And this will be a distance of 720 meters.